These changes in the amount of water in the vacuole, these changes in turgor from a turgid cell to a flaccid cell, are the basis of many plant movements. Now, to understand this further, we'll go back to our mimosa plant and look at its anatomy. At the base of the leaflets, that close, is an organ that's called a pulvinus, or when it's plural, it's pulvini. And the pulvinus is the motor organ which opens or closes the leaflets. And the basis of the opening or closing is the change of the water concentrations, not of the concentration, the water amounts in these cells. When the pulvinus cells are turgid, when there's a lot of pressure within the pulvinus, this pushes the two leaves open. When water goes out of the pulvinus cells, when we lose the turgidity, the leaves snap close. It's sort of like a hydraulic pump. Water gets pumped in, the leaves open. When the water goes out, the leaves close. The way that the plant controls whether the cells will be turgid, opening the leaves, or closed, is by changing the salt concentrations within the pulvinus itself. When you touch the mimosa leaflets, this causes a loss of potassium. We're getting less solutes within these cells. And because of that, as the potassium goes out, the water also goes out by osmosis, and the cells become flaccid, the pulvinus closes. In order to open, the cells of the pulvinus have to absorb water. And the way they absorb water is first, ions are pumped into the vacuole. As ions are pumped into the vacuole, water will then come in by osmosis, leading to turgidity, increasing the pressure, and thus opening the leaves. So if the plant wants water to go into the vacuoles of the pulvinus, let's review again what has to happen to the ion concentrations in these vacuoles. So let's take a step backwards in our process. We've shown now that when I touch the mimosa leaves, this causes a change in the ion concentrations in the pulvinus, which causes a change in the amount of water in the vacuoles, which causes the leaves to close. What's the signal that is connecting between the touch and the change in the ion concentrations? The signal is electricity. Touching of the leaves causes an action potential, an electrical signal to be transmitted down the leaf to the pulvinus, and it's this electrical signal which leads to a change in the ion concentrations in the pulvinus. Just as a little historical aside, this was originally discovered in the early 20th century by an Indian scientist whose name was Sir Jagadish Chandra Bose. He was a noted physicist originally from Calcutta who then became a plant physiologist in the UK. Now, he reported this electrical signal in a lecture in 1901 to the Royal Society, and he tried to have it published. But it was actually Burdon Sanderson himself who rejected his publication. He recommended that it not be accepted for publication in the proceedings. We can only speculate at what his motivation was in rejecting his work, but we now know that actually Bose was completely correct. It is electricity. And Bose had some very seminal findings. I suggest that you take some time and actually read this review of Bose's work, which really shows some of the very outstanding research that this Indian scientist carried out from physics through plant physiology.